A, B and C are points on the circumference of a circle centre O. AOB is the diameter of the circle. Prove that angle ACB is 90 degrees. You must not use any circle theorems in your proof. So quite a bit of information in this question. Let's draw a diagram so we can visualize what's going on. So here's my circle, center O. And I'm going to mark points A, B and C on the circumference of the circle. Well, I was told that AOB is the diameter, so I need to make sure that A and O are on opposite sides. Sorry, A and B are on opposite sides of O. So for example, I could mark A here and B here so that AOB is the diameter. Or I could put A up here and B down here so that AOB is the diameter. Or I could put B over here and A down here so that AOB is the diameter. It doesn't really matter. It's not going to affect anything I do in this question. So I'm going to leave A and B where they are. I'm going to mark C on. It doesn't give me any information in the question about where C needs to be, other than it's on the circumference. So let me put C up here. And I need to prove that angle ACB, I need to prove that that's going to be 90 degrees. How am I going to do that? Well, key thing is I need to mark on the radius from O to C. So because that's the radius, I know that's going to be the same length as the radius here that's from O to A. Which means that this is going to be an isosceles triangle here. Which means that these two angles are going to be equal to each other. So if I'm going to call this angle here x, this angle here will also be x. You don't have to call it x, call it whatever you want, it doesn't really matter. But the point is that this angle here is going to be equal to this angle here, because base angles in an isosceles triangle are equal. So let's write that down. Let's explain that angle OAC, that's the angle OAC, is equal to angle OCA. And the reason for that is because base angles in an isosceles triangle are equal. Similarly, this is the radius here, OC, and also this is the radius here, OB, so they are also the same, which means that this triangle OCB is also isosceles, which means that these two angles will be the same. So if I call this angle here y, this angle here will also be y. And I can say that angle OCB, will be equal to angle OBC. For the same reason, because base angles in an isosceles triangle are equal. Right, now let's consider this triangle as a whole. I know the angles inside this triangle will add up to be 180 degrees. So I know that x plus y plus y will add up to be 180 degrees. So x plus y is equal to 180 degrees, because the angles in a triangle add up to be 180 degrees. Now we can simplify that a little bit. We can call the x plus x 2x, and we can call the y plus y 2y. We can then divide both sides by 2, which tells me that x plus y is 90 degrees. And have a look at the angle that we've got here. Have a look at angle ACB. That is x plus y. So we can say, therefore, angle ACB equals x plus y, which is equal to 90 degrees. And that's what we needed to prove. So key thing here, first of all, draw a diagram, then mark on the radius. Look for your isosceles triangles and label up the base angles as the same letter.